feel free to record minus if you want to start that. Great. So welcome everyone to the next episode of the Solidify show. Today we will have a special guest, Rob from Xspirit, who will talk about how we can use GitHub Actions with a security mindset. So really excited about that. And the one speaking right now is me, Matthias at Solidify. So we usually try to have a host to take care of the logistics for the presenter. So I'll be here, and Magnus Timner is here as well from us. So if you have questions, just type them in the chat. We'll try to save most of the questions until the end of the presentation, so Rob can follow his flow. So that's part of that. And Magnus mentioned that we are recording this, and we will try to mute the ones who forget the microphones. Many of you have probably joined this series of presentations before. We try to cover everything from core engineering practices to agile ways of working, to anything that's interesting in the software engineering field. So if you have any suggestions or feedback about this presentation or presentations that you would like to hear, also feel free to reach out to us to share your thoughts and ideas. Then for those of you who haven't met us, we're Solidify, and we specialize in tools and technologies and practices for building software in a modern way. So we've always been long partners with GitHub and Microsoft, but anything software development related would be something we are always interested in to discuss. And this is a nice channel for us to share things that we've come across and find interesting. So with that, really happy to have you here, Rob. As a long time MVP, it's happy to have a fellow MVP to join from our colleagues in Xspirit in the Netherlands. But I'll hand it over to you, Rob, and you get to introduce yourself and what the talk will be about.
Awesome. All right. Make sure that I can still see the chat. All right. Yeah, let's get started. As Matthias already said, I know Matthias and Magnus for a while. We're doing some community work as well for Global Devs Bootcamp, of course. So it's awesome to be here and to be part of this setup. I want to talk to you about using GitHub Actions with security in mind, because the default things in GitHub Actions aren't that secure. I've been using GitHub Actions since it came out in 2019. I wanted to dive deeper in what are now actually the security implications of using Actions. So what happens when you use them? What happens when a pipeline runs? What could possibly change code in your repository or stuff like that as well? I'll go over each of these actions when you're using GitHub Workflows and go from there. I assume you have some knowledge about how Git works and what GitHub Actions does for you, but I have a small introduction on Actions anyway. On the lower left-hand side, you have my Twitter handle. If you have any questions later or want to reach out for anything, please use that one. I'm fairly active there, so there's a lot of ways from that you can find me. As Matthias said, ask the questions in the chat. I'll try to address them if I can, if it works with the slides. And otherwise, I'll always address them later on, either in Q&A or maybe even create a blog post detailing the questions and figuring out what the answers are. And it's always nice to do that as well. And we'll share the slides afterwards as well, so you can go and follow all the links that you are interested in. But first, let's dive into what are the GitHub Actions stuff that we're talking about. Well, to make sure that we have the same vocabulary, I want to start with workflows. What are actually the workflows that we are executing? Because the workflows are the things that are exercising your actions. They are doing the hard work for you. A workflow can be triggered by lots of events inside of GitHub. For example, it could be triggered by somebody pushing code to a branch in the repository, somebody who creates an issue in your organization, or even comments on that issue, creates a release and stuff like that. All of those things are events, and those events can trigger a workflow. Then the GitHub Actions are the steps in your workflow. So they are doing the hard work. In the basics, it can just be a shell script that echoes something out for you, something that you want to automate away. And you can create your own shell scripts that you execute, or you can create your own actions that you want to use, but you can also use existing actions from the GitHub marketplace. Last time I checked, there were over 8,500 actions available on the marketplace. Things that people already have built, thought it wasn't helpful for them. So it, of course, was doing specific something that they needed. And they share that out with the community, and you are free to use those actions. There's lots of stuff in there, so don't reinvent the wheel. Probably already somebody created an action that does something specific that you want to do, and wraps that in a nice setup. In the basics, we have a workflow example here. In the basics, a workflow is a specific text file that you need to store in .github/workflows. Don't store it in /workflow, singular, because you will be scratching your head for 15 minutes why it isn't being picked up and why the workflow isn't being triggered. Ask me how I know, of course. It needs to be in that specific location, but the file itself can be named anything as long as it's a YAML extension. And in this file, you'll see the trigger that I'm using to trigger this workflow. So this is when the workflow is being started. In this case, this is a push trigger. So when somebody pushes code back over to GitHub, this workflow will be started and it will run for us. In the workflow, there's a job there that I named build and deploy. So naming here is easy to do as well, and you have full flexibility there. And I'm targeting in a specific environment that I labeled production here. The job will then run one or more steps. Each step is then a call to an action or a script that you want to execute. In this case, I'm using the default one, check out my code. So I have my code available on the place where the workflow is being executed, and I can do stuff with the code in my repository. Second step is installing a specific version of a tool that I need. In this case, it's .NET Core. So I'm making sure that wherever the workflow is being executed, I have .NET Core installed with a specific version. And in the last step, I actually build my source code with the version of .NET that I need. This is a very simple overview of how a workflow works, but now we know what a workflow is and what an action is inside of that workflow. So let's dive deeper into the whole security setup. For example, we're going to talk about what happens around your code, what happens in the repository itself and who has access there. I'll go over the runners and how to secure them as well. And then we'll look into the actions and what you need to know to make sure that you're using your actions in a secure way. And lastly, I've got some best practices on how to work with actions by forking them and making sure that your forks are being kept up to date as well. So let's look into repository security. First, we're going to talk about accessing your code, who has access there. Then we'll go a little bit deeper into workflow secrets. And then I'll also talk about your code that's also in the repository, and you need to secure that as well. Starting with access to code, inside of GitHub, you have different levels where you can set permission levels or access levels for people in your organization. For example, at the lowest level, you can do that on the repository, especially if you're running it on github.com, you have a user account, and you have multiple repositories there. But you can also create an organization, and then you can give somebody access to all the repositories inside of that organization. And if you're using GitHub Enterprise, then you also have an enterprise level where you can give somebody access to all the organizations in your enterprise and then all the repositories. And one thing to keep in mind is that we, of course, say as an IT industry, never give a user access right, but always give a team or a group of users access rights. That makes management a lot easier of those setups as well. For the permission levels inside of GitHub, there are different things that you need to know. In the basic, especially if you're running in the enterprise server, if you're not a logged in user, you have no access whatsoever into the environment. For GitHub.com, as soon as you log into that site, then every GitHub user that is being authenticated with GitHub.com has read-only access and can see all the public repositories in read-only mode. The triage level is a little bit extra on top of the read-only access. They can also manage issues and pull requests and do actual triaging there of incoming work. Well, the write access is, of course, self-explanatory. You can actually write things in your repository, but then maintenance level is a little bit extra. They can do extra things like editing the repository description, enable a feature like the wikis or projects, for example, or even discussions, the new feature that is available. But they don't have any access to anything sensitive or destructive. Sensitive information like security scanning alerts, or destructive actions like deleting or transferring repositories, or even deleting packages and releases. So they can do that if you have maintained that. And of course, then the admin has full access throughout everything. Let's look into workflow secrets as well. You can define a secret on the repository level. In this case, I've got two secrets here that I have an example of: publish profile and Sonar token. I'm using the publish profile in the YAML example below, where I use it with $accolade, and you can then target the secrets collection, and you can specify the secret that will be injected during the run of this workflow. This will then be interpreted when the workflow is being run. It will be injected, and then the action can do something with it. And the nice thing about these workflow secrets inside of GitHub is that they're actually secrets. They're always encrypted client-side with a public key that GitHub stores for you. They, of course, have the private key. The UI does it for you. It will encrypt it with the public key locally before it's being posted back to GitHub itself. And if you do that with the REST API, you need to do it as well. And keep in mind that the secrets are not stored within your repository. They're attached as metadata to your repository, so that when somebody forks over your repository, the secrets are not shared with the fork. So they stay with your repository. That's good to know. Looking into who has access to those secrets, it's a little bit high-level access that you need to have to create, update, or delete secrets. At the repository level, you need to have that owner access, so the full maintenance level of the repository. Otherwise, you cannot create secrets. The people that are using them in the workflow can still implement them and read them, but they cannot create them themselves. And if you want to do that at organization level, then you need to have full admin access to the entire organization. And from that comes another nice aspect, is that you can actually set access policies to those secrets. So you can define which repositories can read the secrets and do something with it. That way you can share that, for example, for a whole team, that's where you say everybody who's inside of that team, these specific repositories will have access to this secret only. And that way you have one single place of maintaining the secret value, maybe do some key rotation in there. So you don't have to do that on the repository level itself. So it's good to know that you can do that. And keep in mind that I said, well, it's nice that the secrets are encrypted. Other CI/CD systems can even decrypt them client-side, but you cannot do that on GitHub. But they're only secret until they are actually being used. If you use them in a workflow file and that is being executed, GitHub then will inject it into the workflow as either a direct input to your shell script, for example, or an environment variable that then can be used. And they will try to redact it in the logs, but that value is available for the action as they're doing something with your code. And I already mentioned it, it will be redacted in the logs, but they do that on a best effort basis. They're using a regular expression for that, trying to figure out if the string coming into the log, even before they write it down onto disk, if it's a secret. And if so, they will inject a couple of stars there so nobody can read that value. But if you then use structured data like JSON, XML, or YAML even, you have some weird things in that structured secret setup. There are new line endings there, there are spaces in there, and it's very hard to redact those in the log. So maybe the regular expression won't pick that up. So as a best practice here is if you still really need to do JSON in here, like for example, the publish profile that I had to push into Azure, that thing is one of those structured data files. Remove all the spaces from it, remove all the line endings in there, make it a single string that the regular expression can pick up. Because as I said, well, the action can do anything with it. You need to check what the action is actually doing with it. And it could spool that information over to a third-party API endpoint, out of your hands and out of sight. And that's why I say keep in mind that when you're using secrets, it's very easy to do something with them. And anybody who has access to your action logs can read those secrets then. So if you have a public repository on GitHub.com, then every authenticated user within GitHub has read-only access to your repository and even to the action logs. And it's very easy to spool those secrets over into your logs. For example, I've got a YAML example here where I'm echoing my secret out, and on line 13, echo secrets demo log. That's the default way, and that will be obfuscated by GitHub. But the second one does something sneaky with it. It adds a space character after each character in the secret. And of course, you can already guess the result. On line 6, you see the first echo command, and on line 7, all of a sudden, you have my secret value available in plain text in my public repository that any authenticated GitHub user can see. So be very aware of what you put into your secrets and how those things work, and who then has potentially access to the action logs. All right, what's more in the repository security? Let's talk about your own code on the repository that you're using. And with your own code, I mean anything in your repository goes. Your workflow files, the shell scripts that you might use in the workflow files, or you might use to deploy something into production. Your own code even, but also all the dependencies that are available, that are being used by your application or by your shell scripts. All of them is probably something that you don't want to build yourself. We always say we stand on top of the shoulders of giants. Other people from the community have already created something. And the package that you're using from a package manager or a Docker container image or just a specific layer in your image. You need to have a sense of security around that as well, because those can potentially be executed either during build time or during another step in your workflow on the runner environment that is executing the workflow, and all of a sudden things might happen there. So as a best practice, at least use some static code analysis there for your own code. Make sure that you're not doing something with SQL injections and you're running that in a Q&A environment with automatic testing, and that could potentially be misused. But also think about all the third-party packages or images that you're pulling in. If you go and look into research from open source community repositories, you'll find that at least 70% of open source repos have some way of adding dependencies in their repository. And if you do that at an enterprise organization where we're building on top of SDKs and stuff like that, you could even say that 99% of your code is yours. So scan that code for vulnerabilities. And also make sure that you keep up to date with the latest security updates. All in all, a way to try to protect yourself against being harmed while using workflows, for example. And if you want to see who made changes, well, at the code level, that's of course rather easy. You can go to the Git commit history and you have the full history there and can see what happened and who changed what line. And everything around your code is available inside of GitHub in the audit log. If you do that on the organization level, here we have the Global DevOps Bootcamp organization that I'm part of. If you go to settings and enter the audit log, you can find all the information that is being stored of anything that happens inside your repository that's not specific related to Git itself. Somebody who gave somebody access to a repository will be inside of the audit log. When somebody creates a secret or updates and deletes it, it will be in the audit log. Even when somebody specifically enables a feature inside of the repository, it will be in the audit log. There's even an API for this, so you can hook it up to your SIEM environment, for example, where your security team can do some research on that. You can do a lot of things in there. Be aware of that, where that is available. It's also available on the user level, so you can get to that information always. And usually now GitHub is working the way that if they add a new API or feature in their application, then automatically they will add new stuff to the audit log as well, because you need to know who triggered what things and did things in your repository. All right, that concludes the repository security. Let's dive into anything that goes around your runners. Because the runners are the things that are executing the actions, workflows, all in an environment. You install that as an agent, for example, on your own environment, or you use a GitHub hosted runner. On the right-hand side, I've got two YAML examples here, where the first one, the top one says, run it on an agent that is labeled as self-hosted. So that means you install it yourself and hook it up to a repository. And the bottom one is the default label for a GitHub hosted runner, in this case, running on the Ubuntu platform. There are multiple default images that you can use for that. And the difference between them is, well, if you host them yourself, you install them on your virtual machine, maybe in your cloud environment, you're hosting that on your own compute power and your own networking setup. And that means that all the security around that setup is now your responsibility. You're taking on that load. It does enable you to give your DevOps engineers a specific setup to work with. You might have some code signing certificates that you need to install on the machine so that the workflow can execute it. And you need to maybe have some third-party tooling that you have to install and has to have a license set up. You can do that with the self-hosted runner. And since you're already paying for the compute, GitHub says, well, you don't need to pay GitHub anything for that power. It's free to use, so you don't have any real usage limits on how many actions you can run or how many minutes you can burn there. For the GitHub hosted runners, it makes your life a little bit easier, because now it's GitHub's responsibility to make sure that the operating system is up to date, that all the tools are updated as well, that all the security patches have been patched through. And that means that you're running on their compute, so there's a fee attached to it. Depending on what you're already paying them, you get a certain amount of free minutes. And if you're doing that open source, you have a couple of free minutes there as well. And since they are running it for the entire GitHub.com organization, they of course have a setup where they make sure that a run from organization A doesn't leave any traces for a run on organization B. So they give you a completely clean execution environment with each run that you're doing for that workflow. It also means that there's no caching defaultly available, and you have to do some tricks to get things to work. So you're starting with a new clean environment, and when you're doing a Docker build, for an example, all the image layers will be pulled in always, each and every time, because you have a clean execution. For security, and of course, this is especially interesting when you run a self-hosted runner, you need to think about all the things that the runner has access to. As I said, you install it as an agent on a machine, and that agent gets a user under which it runs. Whether it's a cron job, whether it's actually scheduled as a service, you give it a user that it runs on that environment. So it could have access to anything in your network. Maybe you say, hey, I'm using scripts from a networking disk, hopefully not. And you decide to give that runner access to it. Well, now all of a sudden that runner could potentially traverse your network and do things. So as best practice, keep that in mind and limit down the user that the workflow runner is running on. Make sure that it only has access to the things that it can do, because you're pulling in code from an action repository somewhere that does something for you. Limit it as much as you can. And as an even better step, you can always run the actions inside of a container. There are some actions that cannot run there, but most of them can. In this case, I'm saying I've got a step here that's called my first step. And I'm using a Docker container, and I will be executing my first step inside of the Docker container. So if I run a shell script there, then I'm already confined to the boundary of the networking of the Docker container that's being spun up for me. This gives you a little extra security, so you're not running on the workflow runner itself, you're hosting all of that inside of a specific container that's being spun up for this job. You can also do that on the job level and say, I've got it on the job level, add a container here, I'm running this on an OpenJDK image, and all the steps inside of that job will now run inside of that container. So I can actually use it to do something with Java compilation without installing Java on my workflow machine. It's already in the container, and there's a nice boundary, security boundary around it. So that's a good way to improve your security stance as well. And as best practice, never, ever host your self-hosted runner and then set it up to build something from a public repository. Because what can happen, you have your repository, somebody looks at it and says, hey, I see a small vulnerability inside of this workflow. Let's fork it over. I'm adding some malicious code here that does something with your workflow, and I create a pull request because it's a public repository, you can do that. And all of a sudden your workflow is being executed inside of your networking boundary on your environment. That could potentially be very scary, and it's a very easy way to get hacked, of course. And people try to escape the boundaries and do weird things with it. Same thing goes, you have that runner installed on a virtual machine, and now you could potentially have an issue with persistent data between each run. The first run needs a dependency. Somehow there's a script involved there that overrides your dependency cache. And it leaves just one single assembly there and does something nasty if it's being executed in production. Then the second run comes by and asks the package manager, hey, I need this package with this specific version. And the package manager says, yeah, sure, fine. I've got one here. I've already cached it for you. Have it. And now all of a sudden you have that malicious build dependency already in your build artifact that you can deploy into your environment. And this might sound a little bit far-fetched, but this is exactly what happened with the SolarWinds attack last December. If you want to read more, there's a lot of information inside of this short link. It's case sensitive, so be aware of the capital S. But I'll share the slides afterwards anyway, so you can always find those links. It's a very interesting read on what happened during that attack. They managed to avoid detection, and when they saw there wasn't a possibility to be detected, they injected a single assembly into a dependency cache somewhere that was being picked up throughout the chain. And all of a sudden, I think 6,000 plus customers had that assembly that was compromised running in production for months without anybody knowing. So this is a real viable attack factor that somebody has in your pipelines. As a best practice, don't share those runners, not even between repositories, not even between machines. It's better to have the setup that GitHub has, where you get a clean environment each and every time that workflow is being executed. I've already gone over some of the risk. They could potentially just install a Bitcoin miner and mine Bitcoin on your account. But it could also do really weird things and try to escape the boundary of the workflow runner and try to traverse your network. All right, that's it for the runners themselves. Let's start looking into the actions that you're executing. As we've seen, there are already a lot of actions available on the marketplace, and you can go to the marketplace, figure something out that you want to do. In this case, I've got something that does something with AKS on AWS, and it can deploy something for me there. If you go to the use latest version button, then a pop-up will occur where you can copy and paste over the YAML code that you need, and then you're good to go. Well, the nice thing is that the users part contains the direct URL to the github.com repository that you can find. You can only use GitHub Actions from public repository as it is right now. So you can always go and look at the repository, find out what the action is actually doing for you, and learn more information from there. Because you're pulling in arbitrary code from the internet that somebody else created for you. Any public repository can be used. Well, if you run this, especially for an enterprise within your own organization, it's very scary to run arbitrary code from the internet. But we need to lock things down and try to protect ourselves from just doing that. What can you do? Well, we've already seen that if you use a specific action, in this case, of course, this one is totally non-harmful. You must have it. It's the most awesomest action. I only want to have your secret value. For example, the deployment credentials to your cloud environment. Well, guess where I got that idea for adding a space after each character and logging out your secret to the command, to the logs. Well, this is exactly what happens. And this action is not listed on the marketplace. It's a public repository. It has an action.yaml in it, and that is already enough for a GitHub workflow runner to pick it up, try to compile it, and do things with it. So what can you do? Well, of course, manually, and if it is anything you're taking away from the session today, is look into what the action is actually doing. You're pulling in arbitrary code from the internet, so it's your opportunity and it's your responsibility now to verify that the action is actually doing safe things. So check anything that's inside of the repository there, see if it's not pushing out your credentials out to a third-party API, for example. Check all the container images, all the dependencies, all the layers that are in there. It's now your responsibility to do that check. Well, but couldn't you say, well, only use actions that are actually listed on the marketplace? If you go to the repository, there will be a big blue banner on top of it that says, hey, this is available on the marketplace. Click here to find out more. Well, the hard part is there's no verification process around it. I've even tried to figure out if there wasn't any that I could find. So I created my own action, and within minutes, it's free to use. If it's inside of a public repository, and the workflow will pick it up, and will try to compile that repository for you and run the action. So there's no verification process at hand. They do every once in a while try to scan all the action projects, but that's about it that you can find that GitHub is trying to protect you. Well, what else could you look at? Well, here's something as a verified creator label that a publisher of an action can get. Again, here I went looking, I even tried to read that link here that says learn more about verified actions. And there's not really anything documented on what being a verified creator means. There's also no process that states out if you do these 5 steps, then you will become a verified creator. And since it's not documented, it's an opaque process, in my opinion, you cannot trust it. And the only thing that GitHub states here is says the author of this package, of this action, is a partner that GitHub has worked closely with. And that's it. I have no idea what that means. Does it mean that I have a GitHub.com account? Does that mean that I have a partner set up? There's no real way to tell. And if you go to the marketplace, the last time I checked, even the first 5 pages only contains verified creators. But it's still not a good way to protect yourself against them if that process is so opaque. So what can you do? You could, of course, say, well, limit all the actions altogether. Never ever use actions. It's scary. Bob scared the shit out of me. I cannot use it. Well, I'm a DevOps engineer, and that's, of course, no real good stance. And you need to protect yourself and take up the responsibility and do something for that. You could also say, I want to only allow specific actions. For example, actions created by GitHub. Well, I trust the GitHub engineers, and they probably have a good setup where they only allow signed commits, for example, to a repository, or that the maintainers who can authorize the pull request to be merged have two-factor authentication set up, maybe even have to be a valuable member of the community. Maybe only GitHub employees can do that, I'm not sure. But I trust that GitHub has a good security stance around that actions set. The secondary check mark, of course, doesn't really add any value in my opinion. You can also do, and this can be done on the repository level or the organization level, is only allow specified actions, the actions that you have verified and made sure that you said, well, I'm willing to take the risk of looking at the repository. This one is good to use. Or I trust the maintainer, for example, you can use this one. In this case, there's wildcards available as well. In this case, I'm using a specific action repository of organization that I created, and I trust all the actions that I've stored inside of that organization. So these are my internal actions now. I verify them, assess the risk, and I'm willing to take that risk. At the bottom part, you can even see that they have examples there with Mona Lisa and the AutoCAD, where you can even specify a version number of the action that you allow inside of this repository organization. If somebody uses an action that's not available in the list, even before the workflow is being started, they verify that it can even start and that it can find those actions, for example. Somebody will already immediately get a warning there that says, hey, this action is not in the allow list, please do something about it and get it fixed. So this is a rather good way to protect yourself against those things. What you can also do is pin the action version. This used to be an extra security measure where everybody was using actions without a version. And that meant that you were always using the latest version available. But you can now say, I'm going to look into an action, check the code, what it's doing, and assess the risk again, and say, okay, I'm willing to use version 1. You're using semantic versioning here, so you could say, I want you to use version 1. There's no breaking changes in there. This one is good to go. It's now new that the UI helps you with this if you're using GitHub itself, that you even cannot store the workflow file if the action version hasn't been pinned. So that's already a good improvement there. At least that way you know that the version that you're using should be the version that you check. But if you use it on an editor on your own machine, then there's nothing really protecting you against adding actions without a version. The negative side of using this setup for pinning, version pinning, is that the version comes from a release into the store, for example, the marketplace, where they release a new version of the app. And for releasing a new version, sorry, of the action, for releasing a new version, they use Git tags. If somebody creates version 1, where they commit something into the action repository, push that over, tag it with v1, and then create a release from it. The thing with Git tags is that you can later reuse the same tag on different code. So the maintainer could add more code, tag it again with v1, release it with v1, and all of a sudden you're still pulling in new code with the same version number. So this isn't really a good way to protect yourself against incoming changes that you haven't reviewed. Best practice here is to use the Commit Sha of the action. You create a commit inside of Git. There will be an immutable SHA created that can only be created with that version of the code inside of the repository. Theoretically, it's possible to create a SHA collision, but then the code really isn't looking at all anything like it was before. So this is a unique code that says, this is the version that I've checked. I've assessed the risk. This is the one that I want willing to take in. Use that one. That's fine. And now, even if the maintainer pushes new code into the action repository, you never will use that new code because you're using SHA pinning. This is the ultimate best practice that you have. As I said, even better best practice here that we'll dive into in the end of the session is fork the action repository, take ownership of what is in there, and then limit all the actions in your production organization to only allow incoming actions from your actions organization. I'll show a little bit more about it. Keep in mind that you're putting in sort of a barrier before people in your organization can use it. So enable your DevOps teams as well to take ownership over that setup process. We'll talk about a little bit more about it later on. Because what are we really protecting ourselves from? Well, especially if you're running it at open source on GitHub.com, we're protecting ourselves from anything that's being entered into our organization or repository, and especially with forks of your public repository. For example, you have a workflow file and that's being triggered on push or pull request. Well, that's relatively safe now Used to be that pull request had way too much rights. It runs on the merge commit, so on the code that is coming from the pull request. And it has read-only access to your repository. So you can do things with it without opening up a security risk inside of your own repository. Pull request target is new. That used to be the security setup for pull request, but they are luckily improved that now. It has a higher risk there because running it with this trigger has access to all the secrets in your repository or organization that it's running in. It has read and write access to your repository, so it can do things like creating issues from it and stuff like that. So be aware of what you're doing with a public repository here. If you want to learn more about it, follow this short link. It's a very interesting read on how people have been trying to pwn your pull request, especially on public repositories. Anybody can create a fork and then create a pull request from that. This is an interesting story that's in there from a Capture the Flag event that GitHub occasionally hosts, where they invite the community over to try to hack their way into the repository that they have. So it's a very interesting read. You're protecting yourself from incoming input from a user. For example, the issue title that somebody created, to create a fork, for example, that's being posted back and your workflow picks this up. Even the branch name that they created inside of Git could be potentially be used for attacking your repository. Example of this here is a small piece of YAML where I'm using the GitHub issue title inside of my workflow. And I'm running that with double quotes here on a shell script and try to do something. Well, if I now in my issue title add a double colon in here, all of a sudden my title will be A. And the shell command is being interpreted and it echoes now test out into my logs. So I've already broke out of a boundary and do something freely on the place where the workflow is being run. One way to remediate it, this more information again on that short link, is inject them as an environment variable here. The orange parts here are interesting. The environment variable, of course, will not be interpreted and they cannot break out of that setup. And in this case, I'm still using double quotes that should be single quotes because they will not be interpreted. So make it a real string and escape anything from it. As a developer, of course, everybody knows that you cannot ever trust user input, always sanitize it, and this is a way of sanitizing. All right, let's go into the last part of this session, the best practices around really using actions. And that's fork your actions over. I like to fork them over to my own specific organization where I'm only hosting forks of action repository. And then in my production setup, I say only allow the local actions, but I'm doing that in a different org. So I say only allow select actions from that entire organization. You have to have admin rights to set these settings. So that is a way to protect yourself from somebody using just arbitrary actions from the internet. It has, of course, some positive and negative aspects. The positive aspect is here that you're taking ownership of that repository. That means you have a good security stance and you can verify incoming changes to that repository. It also means that you have a backup of all those actions. Because if you're running that action to push into production, as any DevOps engineer would do, and the maintainer suddenly decides they no longer want to maintain it, and they transfer that repository over to a different entity, all of a sudden your action URL might not work anymore. Hopefully they still let it linger around, but things might happen there. Especially in the enterprise, you want to have the security of the things that are running and to deploy into production today will also work tomorrow. So you take that by forking it over, taking up the responsibility, has the positive side with that as well. Of course, on the negative side, that means that you need to do more work. You're now taking up the responsibility of assessing the security risk there. But in my opinion, you should do that anyway. But you also have to set up that extra organization. You have to describe the process there, train everybody to make sure that they know how to set things up. And maybe even give your senior DevOps engineers the rights to fork those things over to your organization. And you may need to have a way to keeping your forks up to date. So it might put a little boundary in front of using actions in your organizations. So you need to describe that process and really tie things down. But that would improve your security stance, so it's a win. Because keeping all those forks up to date is relatively hard. Because what do you want to do with them? You could go to the marketplace and try to figure out if your action has been updated. But as I said, there are now 8,500 actions there. There's no weekly update newsletter that's being sent out with the interesting parts there. And I wanted to keep up to date with that as well. So I created a GitHub Twitter bot, GitHub Actions, that does all the work for me. It traverses the entire marketplace every couple of hours, finds out if there are new or updated actions, and if so, it will tweet it out. And already by following this bot, I learned so much new technology that is available inside of the community that I never heard of before. So very interesting to do. But of course, this is not just a way to keep things up to date. You cannot wait for that tweet to come by and figure out, hey, I need to update my fork repository. What you can do is two different ways that I have to share that both start with that single step that I said. If there's anything you're taking away from the session, review what the action is doing. Otherwise, you're just blindly pulling an arbitrary code from the internet. Basically, you're asking to be hacked in that way. So let's look in the first one. Use actions, use the Commit Sha, and then set up Dependable to update things for you. Well, you've seen already the use of the Commit Sha. This is what I said. I verified what the action is doing. I'm willing to take in that risk. So use this version. If you then add Dependable to your repository, and for public repositories, it's even free to use, you can say, hey, for the package ecosystem GitHub Actions, verify all the actions in this specific directory, all the workflows that are in there, do that on a daily interval. And if so, Dependable will create a pull request for you. In this case, I'm using it in my GitHub user account on a specific .NET Core web application. It will create a pull request for you that says, hey, I found an action, in this case from my action organization, and we want to bump the version from 0.3 to 0.5. You can see the incoming changes, but of course, in my repository, that's only the line where I specified the number. In the conversation tab, you'll even see release notes from the action publisher if they added release notes to the new release. This also works for the Sha hash that you have in your workflow file. So Dependable can do that for you. Now you at least know that you have the latest version of the action, and you can read the release notes as well, and maybe even go over the commits if you want to. Another way is still review what the action is doing, fork the actions repository over, and then have a process to update all your forks. And then you can still use Dependable if you want. Because if you fork it over and you go to your test repository, in this case, in my production environment, it says, well, hey, I can wait for the UI to say, this branch is now behind. Recently, they even added a one-click button here that I could say, update this branch then. But then basically, you're still closing your eyes, pulling in all the incoming changes and doing things with them. So this is not a good trigger to wait for. And hopefully, people aren't looking at those things daily. As a DevOps engineer, I try to figure out how can I automate that, and there's no real process described around it. So that means I got to create something because I'm lazy. I don't want to do that by hand. That's why I created a repository that you can fork, and it will then update all the forks in the organization where you have landed that fork. So it's still meta, it even can update itself. It contains a scheduled workflow that will create an issue if it sees that there is an incoming update from the parent repository. This is an example of the issue that is running in the GitHub fork updater repository. It creates an issue for me and it says, hey, the parent repository for this action has updates available. It gives you a compare link where you actually look into the code changes of the parent repository, so you can actually verify the new things that are coming in. Do the risk assessment there, and if you decide that it's okay, you can then, this is the review, of course. You can then say, well, I've assessed the risk, and I'm adding a label. It's fine to update this fork. Then another workflow will run inside of this repository that says, well, I'm updating the fork for you. That might take a long time if you have a huge repository, but usually it's rather fast. And it will even then say, hey, the fork has been updated, I'm done, and I'm closing the issue for you. You know, you have best of both worlds where you have an automated setup. You can use the notification system inside of GitHub to get notified of new created issues. You can verify all the incoming changes and then say, okay, I've assessed the risk. This one's fine to use, automate the rest away. And that means that you now have all the pros of forking those actions over. You have a full backup of the action. You have full control over the updates. You can do the security review there. And you now have a central organization with all the latest versions of those actions that you're pulling in the updating in a secure way. And in your production environment, you say, I want to only allow people using actions from my actions organization. Since you now have centralized that security process of updating things and making sure that you're not pulling in weird things, you can now even say, I want to skip the Commit Sha lookup steps that I every time have to take with each workflow that I'm creating. It also means that you don't have to update each and every workflow by hand with the new latest Sha lookup. You can even say, I can skip the dependable setup in each and every repository in my organization because I've deemed it safe to use the latest version. Or otherwise, still use version pinning and then set up dependable to use the latest version. But you've already done the security reviews in the centralized organization. Right, that's the end of this actions and security sessions. I want to stop early to make sure that everybody has a little bit extra time left after lunch. And maybe we can do some questions if there are some. We had an overview of all the things we've gone through. I've got a summary for you of all the best practices that we went over. Make sure that you look into what the secrets are actually doing, what actions are doing with the secrets. And as I already mentioned, if there's anything you're taking away, review what the action is doing. At least start pinning your actions to use the Commit Sha. Don't trust the incoming pull request there. And we went over how to fork those action repositories, limit it in your production setup, have an organization to test with. And I think that's the best practice there of using that setup with forking your actions and making sure that you keep everything up to date. That's it. Thank you so much. Let's see if there are any questions lingering around. I will go over the chat as well. Maybe we can have a discussion there if people are interested. We'll go from there.
Yeah. Thanks, Rob. Like a roller coaster or yeah, high speed. Really enjoyed the session.
There's so much information to share, and hopefully people got scared now.
No, only positive feedback. Not so many questions yet. So everyone, feel free to type in questions or unmute. The one there is more related to Git, but we can try answering that as well. Since we have a couple of minutes. Johan, I don't know if you're still here and want to unmute. Otherwise, I'll just read it out for you.
Oh, please do.
Okay. Right. So this one is about Johan wants to enforce that at least 2 people are involved with every change made to a protected branch. So in GitHub, by default, we have a reviewer to approve. By default, allows a reviewer to approve their own changes to a pull request. Which makes it possible to use any open PR to merge changes possibly for making an attack on the production environment. Do you have any guidance on how to avoid such a scenario?
Yeah, you can set up branch policies. If you go to the branches section inside of the repository, you can set up a branch policy and set things up there where you say, for example, that branch that is the merge request needs to be built and run through all the checks that I've set up. And then you can even say that the reviewer cannot approve their own changes, for example. And then when somebody pushes in changes, then the reviewer will need to review again, stuff like that. But you can also look into the code owner setup, where you can say, if somebody touches, for example, my workflow files, I want somebody with a security mindset to also have an extra set of eyes on this change. And that's another way to protect yourself against weird things being popped in.
Yeah, great advice for the code owner file. I will check into it.
So it's very awesome thing that they've added, and it's very sneaky to find it. It's literally called code owners in full caps.
Yeah. Yeah, that's a less known practice to use that, but I agree it's really useful for scenarios like this, or where you want to have a clear ownership of parts of your repository.
Yeah. Maybe even lock down the package JSON, for example, or the package lock JSON, stuff like that. You can really set a fine-grained setup there. Very helpful.
Great. I have another one from Christine.
We even have people from Kuala Lumpur joining. Welcome. Awesome.
Yeah. Nice to see. So Christine asks, would you recommend actions always to be executed in containers?
I try to use them as much as I can. I like the extra boundary that it gives me, because now if somebody wants to attack something, they need to break out of that container first and do something, but they do still have the access that you gave the runner or the workflow itself to the repository. So if you're running that with pull request target, they can still do something against the GitHub API because they have that right authority there. But especially in your own network, limiting it with another layer of security around it, I like that a lot. Yeah, exactly. Yep. They both need to find a security flaw, both in Docker, because it's running in Docker. So they need to break out a couple of layers and even Linux windows. But you can also run your workflow runner inside of a Kubernetes setup, for example. So it's another layer of extra protection that you can add around it. But as I said, if you're running it against pull request target, they have right access to your repository, and that's already very scary if you want to do that. So if you have that setup of public pull requests coming in, make sure you have a basic workflow that verifies that nothing really bad is happening. Add some code owners there, for example, on your public repository, that nobody that's outside of your maintainer community can add workflows, for example. And then you need to have an extra security review. Do all those security checks there. Then enable them to add a label on the pull request, for example, because you can only do that when you're a maintainer. And then run the secondary workflow with pull request target, because you've already verified it's not that scary that the incoming changes.
Yeah, and the takeaway I get from your session is that it's a bit scary, but that this isn't on by default.
Yeah.
But of course, it comes with a price, like you explained in a good way, that you need to have a governance process. But yeah, that's how it is. If it's internal only and we trust people on the inside, then possibly we don't need to do this. But still, a really good idea to have these practices, even if it's only internal repositories.
And the same story goes for other CI/CD systems as well. Even if you're using GitLab or Azure DevOps, it has the same security things that you need to manage and have some governance around. It's not unique to GitHub Actions.
No. It's just that GitHub Actions is flexible enough to handle implementations or give us solutions for the problems.
And it used to be the default guidance that they said, whenever you start using Actions, fork it over first to your own organization or your own repository, and then only use from there. But somehow that got watered down during the years. And now the default is, hey, it's an action from the marketplace, just use it. It does awesome things. Yep. Go for it. Well, especially in an enterprise setup, that's very scary.
Yep, I agree.
Is it possible to run the GitHub Actions in self-managed Kubernetes cluster in cloud? Yes, it is. It's a community effort that is being done there. I'll find the link. I had it yesterday. I was testing it with it even in AKS. But it's a very straightforward way where you can have an ephemeral runner, so that's only available during the execution of your workflow. And B, you have a way to scale your runners as well. You're running that on an AKS cluster that you can even auto-scale if you want to. And then you can say, instead of just adding 10 workflow runners with some compute power behind it, you can say, I want to scale it between 0 and 100. It's an awesome setup that we've seen. I'll share the link later on.
Yeah, that's an interesting topic in itself. It's really a deep dive or nerdy, but maybe we want to do a session on just how to manage your build infrastructure.
So when you start thinking about self-hosted runners, that's one of probably the second question. The first one, it's nice it can run on a virtual machine. Then the second one is probably, but I don't want to run it on the side of a virtual machine. Yeah, that's scary as well.
Indeed. Yep.
Yeah.
Great. All right, so we'll post the link to the recording, and if you want to share the deck, feel free. We'll post it somewhere as well.
Yeah.
And with that, everyone gets your contact information and whatnot. So I'll share the final slide, I guess. So we're ready to wrap up. For those who need to drop off. So again, thanks all for joining, and thanks Rob for a really good presentation. We'll again share the links and the contact details if there's a desire to extend the conversation. Otherwise, we will have a new event already next week where Mihai from Solidify will, together with me, share thoughts about app modernization on the Azure stack, how we should and can think about taking our classic applications, put it like that, and modernizing it. So looking forward to seeing hopefully most of you again next week. Great. So I'll stop the recording.